So today we are going to cover 7.1, and in our next class we are going to do a review, and then your exam will be next week Monday. I posted the review sheet already if you haven't noticed. Let me show you again. It's on Brightspace, and this is the review sheet. So exam will be based on 3.5, 3.7, chapter 4, 4.1 to 3, 4, 5, and based on today's materials. So we are done with actually everything. We finished substitution in our last class, and today we're going to do 7.1, and we're not going to do many examples, few examples, but the material should be fun and it takes time. Any question before we start? Any question? Apollo? No? Comments? Concern? Complaint? Anything? Okay then. So we learned how to do antiderivative. We learned two rules. One is the power rule. It means we add one with the power and then we divide by the sum. And then we learn about U substitution, where we have the original function and its derivative together. If you have that scenario, they can use substitution. And now, based on that antiderivative, we are going to find area between curves. So at the beginning of chapter 4, when you talked about antiderivative, and we didn't have an in-person class, but I gave you a link to watch. In that recording, they were talking about area under the curve. Area under any curve is the antiderivative. So we are going to find the same thing, area under the curve, but not only one curve, but between two curves. We are going to do the same thing. We are going to find the area, but this time we look at the area specifically between two functions. So let's say we have two functions. One is y equals f of x, and one is y equals g of x. If the f of x is always bigger than g of x in a specific interval, then we can find the area by taking the antiderivative of the two functions, the difference of the two functions. Now, at the beginning, we learned that if we divide our area between the curve or area under the curve into many rectangles, the more rectangles we have, the better approximation we have to find the area. That's how we take the limit of the differences, limit of the sum of the area of the differences between the two functions. In other words, we want to see if we make rectangles very small and we have infinitely many rectangles, what would be our area? So since you're taking the limit, it tells us to, hey, take the antiderivative directly. It will be same as you have many rectangles. You're dividing your area into many rectangles, and then you're taking the sum of all the rectangles, sum of the area of the sum of the area of all the rectangles. It's the same as the direct antiderivative of the difference of two functions in any given interval. Okay, so that's how we connect the area between two functions or area between two curves with the antiderivative. Because in order to get the area, we can use many rectangles, take the limit, or you can simply take the antiderivative and then you get the limit of the area. Okay? Any questions so far? In other words, all you have to do is take the difference of the two functions you have, and remember, in that specific interval, one function always has to be bigger than another function. So if you have that, then you can take the antiderivative by taking the differences of the two functions in that given interval, where our limits are the interval. The lower limit is the left side of the interval, upper limit is the right side of the interval. Okay? So we have two types of scenario. All this time we had function y, sorry, x, y is a function of x, x is a function of y, x is a function of y. So we had y equals f of x, y equals p of x. What's wrong with this? So if you have a function where x is the independent variable, then you can take the antiderivative of the upper function minus the lower function. And our limits, the left side limit is the lower limit, and the right number of the interval is the upper limit. And then we find our area by taking the antiderivative of the difference. Or we have a function where y is not a function of x, but x is a function of y. So it's the other way around. Y is now the independent variable, x is the dependent variable. If we have that scenario, then we take two y values between which we have two functions, and then we subtract the left side function from the right side function. Take the antiderivative, evaluate the limit for that two y values. So if y is independent, our limit has to be the y values. If x is the independent variable, our limit has to be to x values. Okay, and you always set to the smaller area from the bigger area. If you don't know which one is smaller function, which one is bigger function, there are two choices. Take an x value and substitute in the function to see which one gives you the bigger y value. If we have the left side scenario, whatever gives you the bigger y value, that means that's the bigger function. So you set to the smaller function from the bigger one. Or you do the same thing. You take anything between two x values and you see your two y values and see which one gives you the bigger number. The bigger one will give you the bigger function. And if you have no idea what to do, just subtract one from another. If the area is minus, that means you have to change the sign into plus, because area cannot be minus. Okay? That's the scenario behind what you're going to do today. If you have the left scenario, take the antiderivative respect to dx, respect to x, so we are going to have dx. And if we have y as independent variable, we are going to take the derivative respect to y. So we're going to have dy, and our limits will be the y values. Question? In other words, if you have dx, taking the derivative respect to x, you subtract the lower function from the upper function. But if y is the independent variable, so you're doing dy, that means you're going to subtract the left function from the right function, and your limits are y values. So these are the important information we need to know to do all the questions from this section. Since you are not allowed to use graphing calculator in class, so for the exam, you actually have to find which function is bigger or which function is on the left. You have to find it manually. But for your homework, you can use the graphing calculator and you can see which function is bigger. So you can separate the smaller function from the bigger function. Can I flip my page? Hmm? Louder, there's some noise about us. We didn't skip. I give you the link to watch for 4.1 and 2. And then the last section is 7.3, which we're not going to do. And we have only one more section to do, 7.2. Besides that, we cover actually everything. Do we have 5 and 6 in our syllabus? Let's see. That's. We do not have 5 and 6. So yeah, I'm following this syllabus from the department. Or you mean chapters? We skip chapters. Oh yeah, they skip that. I don't know why. Probably because we don't have time and they wanted to learn the most important information you need to know for Calc1 students. Okay, then let's see. Oh, I actually forgot. What type of information, what type of question we are going to do for this section? Okay, so we have a scenario where they give us the picture, so we are lucky. They're telling us that we have x equals y square minus 6y, the red function. X equals 3y minus y square is the blue function. Blue or purple, whatever. Is it purple or is it blue? Blue? Okay. I actually have a hard time distinguishing blue and purple. Sometimes they look so much alike. And they gave us 2 points. One is here, 0, 0. And there is another point here where x is negative 27.4 and y is 9.5. So this function, which one is independent variable, x or the y? Y. That means we are going to follow the bottom one. Right function minus the left function. So the area which we are looking at is this area between the two curves. To find this area, this is same as we are going to the y values. So which two y values they gave us here? 9.5 and 0. So lower limit is 0, upper limit is 9.5. And we are subtracting the left from the right. So left function is the red one. So minus y squared minus 6y. Our right function is the blue one, 3y minus y squared. And we are taking the derivative with respect to x or respect to y. Which one? Y. So it's dy. Why did I put the parentheses on y squared minus 6y? We are subtracting the entire function. That means the sign will change. So, in other words, we have entire derivative from 0 to 9.5. 3y minus y squared minus y squared plus 6y dy. And as we see, we have like terms. So combine them first. 3y plus 6y, how many y's we have? 9y. And minus y squared minus y squared. Minus 2y squared dy. So it becomes simple, only two terms function. We take the antiderivative of each term. What is the antiderivative of 9y? So we have 9 y squared, and then we divide by 2. So let me put the 2 below 9. And then we have 2 y squared. What's the antiderivative of y squared? y to the third, and then we divide by 3. So let me put the 3 below 2. We don't have to put plus c because this is definite integral. We have our limit y equals 0. So if you want, you can write y equals 0 and y equals 9/2. So all we have to do is our substitution. And we subtract one portion minus other one. So 9/2 square minus 2/3 9/2 cube. That's the upper limit. We substituted with 9/2 otherwise. And now we are subtracting the lower limit. When you subtract, both of them get 0, right? Because when your y is 0, both terms become 0. So basically, we're subtracting 0. So we have 9 cube over 2 square. And here we have 2/3 9 cube over 2 cube. I mean 9 cube because we have 9 square inside here. And 2 cube actually, my bad. We have 9 square and then 1 9 outside, so 9 cube. We have 2 square and then 1 2 outside, so 2 cube. 9 cube over 2 cube, and then we have 9 cube over 2 cube with the 2/3 in the front. So basically we have 9 cube over 2 cube, 1 minus 2/3. I have space now. So we have 9 cube over 2 cube, and then 1/3, right? 2 minus 2 is 1/3. So whatever that is. Oops. I'm not simplifying, but I'm giving the answer. The answer is at the end, it's 243 over 8. This is the final answer. Okay. I skipped the algebra. You can do the algebra by yourself, but the final answer is 243 over 8. Question? When your y is independent variable, you subtract the left function from the right function. Obviously, this is right, right? This is the right. Oh. Yeah. So this is right, and this is left. Okay. So subtracting left from the right. So right minus left. Our right function is that telling us here, the blue is right, and the red is left. So right minus left. Mm-hmm. Like this one. In this example, which one is independent variable, x or the y? X. That means it's top from the bottom, top minus bottom. And our limits are between the two x values. Unfortunately, they did not give us the x values, our limit. So in the left example, they gave us the two y values. So we didn't have to do anything. We simply got them from the picture and then we put them in the integral. But here they did not give us the limit. Any idea if they do not give us the limit, how can you find the limit? Good job. solve for x where they intersect. Somewhere they have to intersect. And then you have to see where exactly they intersect. So we set both of them equal to one another and we solve for x. So to find the limit of the integral find the points of intersection. If they don't give us the lower limit or upper limit or any limit, then we have to find them. So 2 root x equals 2x. And now our goal is to solve for x. The algebra, how do you solve for x? We can divide by 2. So they cancel out. We have square root of x equals x. And then you can do it mentally. What number, if you take the square root, becomes the same number? Definitely 1, right? One of them. But is 1 the only solution? Why take the square root to get the same number?
0.
Also 0. So if you do it logically, you don't have to do any math. You can see directly. But let's say in the exam, your brain is not working. So you cannot think of the two numbers. Well, no problem. Then you have to solve it algebraically. If you do want to solve it algebraically, what do you think we should do now? Okay. If you want to square, no problem. Square root of x squared equals x squared. So we get x equals x squared. So subtract x because we want to see 0. So 0 is x squared minus x. Factor. So we factor out x. And now we can see clearly, right? Our answer is x equals 0 and x equals 1. See? Exact same two things. So you can use logic or you can use algebra. It's up to you, whatever you have to do. So we set up. We can set up, but we want to know which one is bigger and which one is smaller. So you have two choices. Either don't care and then do the math. If you do that, your points will be deducted in the exam. For homework, it's fine. But for the exam, points will be deducted. So you should know how to find which one is bigger. So we are looking at only the interval from 0 to 1. So pick anything between 0 and 1, substitute in both functions and see which one gives you the bigger number. That's the bigger function. So what number you want to pick between 0 and 1? 1/2. So if x is 1/2, y equals 2 square root of x and y equals 2x. So this becomes, let's pick 1/4. So we have 1/4 here. Oh, and this is 2x only. And we have 2 times 1/4. So square root of 1/4 gives us 1/2. And here we have 2/4. What is half of 2? 1. And what is 2 divided by 4? 1/2, right? So which y is bigger? The square root. That means that's the bigger function. Bigger function. That's how we determine which one is bigger. If you think of graph, sure, you don't have to do any math. So square root is this, and y equals x is this. So from the graph, we can actually see you're looking for this interval. This is 1, this is 0, this is square root, and this is y equals x. The 2 just kill them, that's it. 2 is not a problem. So if you look at the graph, draw the graph. If you do it algebraically, show your work. Now we have all the information. That means we can go ahead and find the antiderivative. From 0 to 1, our bigger function is 2 square root of x. We are subtracting the smaller function 2x, and we're taking the derivative with respect to x. So in antiderivative with respect to x. So what is the antiderivative of 2 square root of x? Square root of x is same as x to the 1/2 power, right? So what is its antiderivative? You add 1, you get 3/2. So x to the 3/2, and then divided by 3/2 means multiplying by 2/3. And then the next one, antiderivative of x. X squared over 2. And it's definite, so from 0 to 1. So in other words, we have 4/3 x to the 3/2 minus x squared from 0 to 1. Again, when both of them are 0, everything becomes 0. And when x is 1, we get 4/3 times 1 minus 1 squared. In other words, we have 4/3 minus 1. 1 with any power is 1, right? That's why 3/2 still gives us 1. And what is 4/3 minus 1? 1/3. So the area between these two functions is only 1/3. So when you have normal function, our life is easy. It's not very much hard, right? Either we have in terms of y, in terms of x, whatever we have, we just subtract them, take the antiderivative. But how about we have something that is not so normal? We have absolute value of 6x, and we have a parabola x squared minus 7. Here, anytime we have absolute value function, we have two choices. Either it's positive 6x when x is bigger than 0, or it's negative 6x if your x is less than 0, bigger than or equal to 0. Okay, so for absolute value function, we have to split them apart. And for your convenience, I have the picture here. We have, please texting. Oh, Andy, you're online. Sorry, I didn't see your function. I didn't see your chat. Yes. Yes for both answer. We pick any point between 0 and 1 because those are our limits. And for the second function, if your function crosses more than more than once, then we have to split our limits into two pieces. So split our interval into two pieces. For example, here, This portion here is negative 6x. But this portion here, oops, this portion here is positive 6x. So we are not actually dealing with two functions, we are dealing with three functions. And the bottom one here is x squared minus 7. So we have an intersection here, intersection there. We are intersecting twice, but we have three different functions. So that's why you have to split our integral into two pieces. One is from that point to 0, because here our function is negative 6x. It's a bigger one, and you're subtracting x squared minus 7. And then from 0 to the next point, our function is positive 6x, and you're subtracting x squared minus 7 function. Now we can see 0 directly, but the question is, what are those numbers? Why they're intersecting on the left and intersection on the right? What is this number and what is this number? We need to know why they're intersecting. So we do the same thing twice, one for the positive, one for the negative 6. So for the left function, we have when x is smaller than 0, we have negative 6x equals x squared minus 7. We want to see for the negative x, where they're intersecting. Also, we'd like to see for positive x, where they're intersecting. So for positive x, our function is positive 6x. And we have x squared minus 7. We are doing the exact same thing twice. So if we add 6x and subtract 6x, we get 0 equals x squared plus 6x minus 7. And here 0 equals x squared minus 6x minus 7. They look almost same, but definitely they are not same. What two factors we get from here? Which numbers? Let me make the volume higher so if he speaks, I can hear. So MD, you can speak if you want instead of writing. So here, what do we have? Which two factors we have for the left one? Two numbers multiplied to negative 7 combined to positive 6. Positive 7 and negative 1. That means we get x equals negative 7 and x equals 1. Right? Do we accept both solutions? See, the trick is here. For all those x which are negative, this is true. But x equals 1 is not negative. So we cannot accept this as our solution. So only x equals negative 7 can be true because this is negative. Similarly, for the right side, which two numbers multiply to negative 7 also combine to negative 6? Xian. Negative 7 and positive 1. So this gives us x equals 7 and x equals negative 1. So for this side, which number we accept, which solution? 7. Because we are looking for the x value, which is positive, and this fulfills the requirement. X equals to negative 1 is negative, so you have to skip that. That means the two intersection we have here, this one x equals negative 7, and this one x equals positive 7. So we have two intervals. from -7 to 0, and then from 0 to +7. What do we write for the interval -7 to 0? The left side. What minus what? Go ahead, Apollo. -6x minus x squared minus 7 dx. Because see here, -6x is bigger. And what do we write for the other one? Positive 6x, good. Positive 6x minus x squared minus 7x. They look almost same. The only difference is one has -6x, one has positive 6x. So -7 to 0, -6x minus x squared plus 7. And here 0 to 7, positive 6x minus x squared plus 7 dx. And then we find the antiderivative. Let me write this nicely. It looks crooked. -6x minus x squared plus 7 dx. So what's the antiderivative of -6x? Let me x one by one. Go ahead. Antiderivative of -6x. -6 over 2. Perfect. So it means we have -3x squared. Look on the next one. Antiderivative of -x squared. X cubed and then divided by 3 means 1/3. Okay. 1/3 x cubed. Jihad, what's the antiderivative of 7? 7x. And we're taking the limits from -7 to 0. Sanzim, what's the derivative of 6x? 6x squared, right? 6x squared over 2. So that gives us 3x squared. And then you already did x squared, so x cubed and 1/3 and 7 is 7x. For this one, our limit is 0 to 7. So for the first one, our limit is -7 to 0. For the second one, our limit is 0 to +7. Yeah. So you have to do same thing twice. One good news is that when it substitutes 0, everything becomes 0, right? So 0 minus. Then you substitute -7. So -3 times -7 squared minus 1/3 times -7 cubed plus 7 times -7. So this was the first part. Now for the second part, we add same thing. 3 times 7 squared minus 1/3 times 7 cubed plus 7 times 7. Yeah. So many numbers. Now, because of this minus, all the sign here, they will change, right? Because they're subtracting. So we have positive 3 times 49, positive 1/3 times 7 times 7 times 7. So basically 49 times 7, 63, 343. We have negative 343 for negative 7 cubed. And then we have, because of this minus, this will turn into minus, right? And this minus and the negative 7, they will turn into positive 49. Yeah. So plus 3 times 49 from the bottom minus 1/3 times 343 for this one, and then plus 49 for the last one. Plus and minus, they turn into minus, so let me just put minus here. So basically we have same thing twice, right? So if we add one thing, just double it, and then you get the result. Now tell me the answer. Go ahead. You can do one line and then times twice, because you have the same numbers twice. Actually, we didn't have to do all these things, because we can see clearly in the picture, we have the exact same area. So if you take only one side of the area and multiply by 2, you get the entire area. So we just wasted our time. So what's the answer? What do you have? 3 and 49, you have 149. So basically you have 449, 4 times 49. And then you're subtracting 343 divided by 3. And then times 2. No one is doing the math? Come on, guys. Your exam is exactly 1 week from today. Expect to see this type of question in the exam, definitely. At least one. So it's a good practice. Go ahead. Any answer yet? Ellen? 490 over 3. Wonderful. He did it mentally. Great job, Ellen. Now I have 2 questions for you. One is algebra, one is trig and algebra combination. Go ahead, have fun. Enjoy. And I have the answer, so you can check your answer, whether you got the correct answer or not. Well, let me take the attendance. Kimberly, Harry, Judith, absent, Mac, Ziad, here, she, here, Jocelyn, here, Lucas, here, Logan, here, Ellen, here, Musfika, here, Nick, not here, Sanzim, here, Shion, here, Raka, absent, Ella, here, Apollo, here, Andy, online. Okay, so 1, 2, 3, 4. And I actually have one more question with these two, which takes a little bit time, so let me test it again. These are from your homework, so if you do them here, that means you are doing your homework. You don't have to struggle alone, you can talk to your neighbor, do them together. What time is it? 24. Yeah, but these are zeros. And these are not zeros. These are intersectional. Where they intersect. When the two functions are so it's called the number between those options. What's new? Find the limit of the one given the limit. Okay, that means you have to set the equal with the legal. What you need to know is the legal. So it's not it doesn't. You have to find which one is bigger. So pick a number between these two numbers and see which one is bigger. Oh, so we use something different. So this is the limit. The anti you're going to use the -1 to +1. And then you have to see also yes, we have to actually set the equals because sine is a periodic function, right? So maybe in one period it's bigger, maybe other period smaller. So maybe in this period, in one portion is bigger, the other portion is smaller. Okay, so I could just choose a value here, put that into the equation. No, they're going to give the same. They're going to they'll give you the same number, but you're looking at where in between. Do you have anything where they intersect? The problem with the sine function, sine, cosine, they're periodic function. When you deal with periodic function, you have to see the two functions you're dealing with, do they intersect with in the limits, or they intersect between those limits? So even if they give you the limits, you still have to set them equal to one another to see between them, do you have anything that's intersectional? And at least in between them, then would it be like -1, that's what -1, and I have to do the interval 2 times. So it's a fast step here to set them equal and see if there are any other intersection points besides this two. If you find one, then you have two intervals. And then for each interval, which one is bigger? So from each interval, between each interval, you take one point and find the solution is bigger. Or you can use the graph. Yes, line graph and use a linear graph. So it's -1 and 1. And then now we need to go out of it. It's fine. Finding out all the excess, it's true. But this will not be true. Or you can only have all the access like this one. For 0, whether it is 0. Can't see anyone. Exactly, that's the intersection. You need to know between 0 and 1, which one is bigger. Up on the bottom. So pick anything between 0 and 1. So which one is bigger on the bottom? Or use the bottom. In the second one, sorry, I love to see it. Now we see it. How did you find 0? What did you do? So you use a graph. I mean, how did you do it? You did this last. So how did you find 0 between them? Did you use a graph? So you are using graph. In the exam, show you graph. So I can see. Even though I know you know everything was T. How to feel points. It ended up to that because this is harder than last one. So in the note I have this class, but then I know well if you know that this one to use it. It has three choices. For in-class exam, you can use graph. You know how to draw the sine graph, right? And this is y equals x. So y equals sine graph and y equals x. Graph that and see what they intersect. You don't have to be perfect. You just need to catch, just visualize it. Second choice, do it logically. What number you can put here so that the result will be the same after you put the sign. Or the third choice is the jumping calculator and find out the intersection. But in the exam, it's not allowed. That's the best method, I think, the graph. Like you don't have to graph, you don't have to be exactly graph everything. Just catch a graph and see how they intersect. Because area can never be met. Why are you having anything? Because that two function is subtracting, they're wrong. Is subtracting the bigger function from the smaller one. So it's to subtract the smaller function from the bigger one. So you have to find out which of these is smaller and which of these is bigger and pick a point between your limits. So between 0 and 1, pick any number. And then put here and see which one is bigger. Why? That would be the first function and we just subtract. Something is not right. This is a cube, this is square. 8 times 1 is 4 square. You're getting much better. 8 times 1 and much times 1 to give you easy English. That's it. But maybe this is a bit why I got your upper function. Is it 1 or 3? At the same, do they look same? No. So, especially about the last one, right? So yeah, you have to find both function, both area. So 1/7, one of them is 1/7, right? 1/15. Sorry, it's 14 minus. There's a typo. This is 14. What is are they intersecting? In one part, there is one alpha function, in the other part, there is another alpha function. Once you can find one area, transfer it to say same area. So find one and then multiply it. With this symmetry and you get the exact same area. But for the right one, you don't get an exact same area. So to find both areas. Anybody needs help? Okay. What you are trying to find here? Okay, I'm good at which, but at 0, what are they saying? That means between here, they are intersecting one more time. Which means they have to split this interval into two pieces. Anytime any interval in the intersect again, it just splits into. So good thing is starting with 0, so you can see both of them do the same number, 0. That's right there. So you can find negative 1 to 0 or 0 to 1. And then positive 2. But in that interval, you need to know which one is the. So you need to find a number which if you are doing from 0 to 1, you need to find a number between 0 and 1, lying into what function is sufficient to when you're doing the other one, negative 1 to 0, you get negative number and solution is 0. Good. Oh, also got one light. Do we move on now? So the last is to have a topic before before that you use all the pieces to do all make sure with as high score as possible. Oh, this is Shahera? So cute. So yeah, it's true. When x is 0, sin 0 is 0. And then you have two other limits that give you negative 1 and 1. Negative 1 to 0, 0 to 1. Now you have two choices. They are symmetric, so you can find only one of them and then multiply it. Either you can do this or you can do that. But whatever you're doing, you have to know in this interval which function is bigger. Otherwise, they end to that negative number. So did you test with the number? Yeah. With which number? 0.5 positive and negative. That means we are doing this interval. Because 0.5 is lying here, right? Like here. Yeah. So in here, which one is bigger sum? Easy. Oh, are you done with the second one? Did you get the same answer? 0 to 1. Okay, that's right. X functions. One. I actually don't have the answer. 7 to 10. Well, it's a test. Usually it's not. If you just random, we eventually get the results. And then if you results in this gap rate, we get negative results. So when you know you make it can apply the changes to substitute here and see which one you see the number. If it's true, but trees outside of the limit, that doesn't help you to figure out what between that. For example, what do you think it was the need numbers? Why is it so much? What's the integrity of this? Good. Do you have the substitution you do plus plus? Lots of questions. See what did you do in substitution? What is that? What they can tell you to the whole B, you have to use substitution for the second question. And also for the third question. Because these are trig function. Trig function means use substitutions. If you have all these that will be X. Possible from -1 to 1. Calc1, both functions are going to set. So you cannot take one and take exactly. So anytime these interval from more intersection, it's just to change the number. And now you to know which one is bigger or first. So in this interval, compare to one first. Which is the opposite. Then like it actually, but So you're going to do 1 and positive 2. Holy cow. What's that I do to all? So. And it's in the nations. No, we only have the GX, the GX. The substitution is only for this one. This one is normal partial. Conjugate partial. So this is fine. But the substitution only comes for two partial. So change here. So if I put this here. So writing it once and writing it twice. Okay. So here is dx is so for dx here. You can never be on the denominator. So the same thing, this is equals dx. If you figure out wrong, you can never be on the denominator. You always is the numerator. So du is on the top, on the side. Yes. So otherwise, nothing idea. Remember in our last class, we learned substitution. So we have one plus one of them is to review so that you can see the number. But if you do the function, you must be in here. Now, if you think the U is sine, your G is cosine. G is equals to it is taking another sum. It has to be this one. So if it is under x, what is the U? I want to ask which remove the so they not exactly but U is at x, T is at y. Yes, we need to solve for the next individual business to explain the software DS into actual sites. The development direction is not mutually. So you can't get one has is new as a result of the gas in true I is constant, so continuous. So we have one hexagon so print result. We have one integration of sign and last mention upside down. But we are not giving you, so you have to replace your view with what we have. It is your to keep your equations. One class. Like no routine, who's moving from 0 to 1. How do you do that? Register x 1/2. What is the u? Only 1/2? Only 1/5? The u is an x, right? Same Mr. X before. But now let me see. So you are going to evolve to limit from 0 to 1. To substitute x with 1, x with 1, and y is equal to 0, x with 1. Then whatever is what you want to do this one. Are you guys done? Um, the two engine cancel out. Why do you have to find the top on the bottom? This one. This is not one of the time. And one here, we have one half. Good. Now let's take the last one. I'll give you guys 7 more minutes for the last one. 2 over 7. This is right. And then what do you have here? Really, you're evaluating at 0 and 1. So 1 is 1/4. And this is 0, okay. And you subtract equals and 0. And what happens to the x square and then this is a highlight from so you're minusing substitute 1 and then minusing 0, right? So how many minusing? So this is only between 0 to 1. Yeah. But how many intervals is that? 2. Or no, 2. So you multiply twice the sum. Oh yeah, that's because your function is wrong. How do you know this function is bigger? 0, 1. So 0.5. 0.5. So 0.5 to 1 point. And 0.5. So we have pi about 4. Pi about 4 is 25. So 25 is virtual. Sine is yeah. So sine is from 0 to 1 sine is given, and from -1 to 0 our function is given. After your function is given. So 0.5 is between 0 and 1. So you have to put 0.5 in both functions.
Yeah, I accidentally.
Negative decimal. That's what the sign is wrong. So you come back here and you replace everything. No, this is your u. Derivative of sine, antiderivative sine is negative for some. So you have to put your u here because this is your original one. Now the dx, if du is wrong. Okay. So since we are dealing with two different functions, you should separate your dx. One for this one for that one. So if we do that, we have 0 to 1 sine pi over 2x dx minus x dx. And then use interval, and then interval 1. Now for this part, this becomes sine u, and your dx is 2 over 5. Now this one is constant, so keep it outside. So 2/5 integers was sine u du. Energy density. And remember, this one only goes with different ones. This one has been. So instead of taking it out, write it once. So you have 1/2 times 2 is what? So 1/2 times 2/5. 2 and 2 cancel out. So you have 1/5. And what is integrated sine? Plus sine. But I did not, we were not giving me the what was given to us. So in this case, 5x. And then we don't have to. No, first you change here to get this situation. Once you click enter, you will replace that. What will replace it? Maybe to that here. Okay. Let's start doing them together. Don't have anything from Andy. No. Okay. The first one is easy. We have to see where they meet. So we set them equal to one another. 4x squared equals 8x minus 4x squared. Let's subtract 4x squared from both sides. So we get 0 equals 8x minus 8x squared. We can take out 8x, the common factor. We get 1 minus x. That tells us x is 0 and x is 1. Or, never mind. And then we look for which one is bigger. So you take any number between 0 and 1 and you substitute, or you can use the graph. If you do want to use the graph, this is an upward parabola, and this one is a downward parabola, right? Because you have negative 4x squared, downward parabola. So from 0 to 1, this is the scenario. This is 8x minus 4x squared, and this one is 4x squared. If you're good with the parabola, then you know this is the scenario. This is 1 and this is 0. But if you're not good with the parabola, that means you have to know which one is bigger. So you pick a number, let's say between them we have 0.5, right? 1/2. So here we have 4 times 1/2 square. That gives us 4 times 1/4, 1. And here, let me erase my parabola. We have 8 times 1/2 minus 4 times 1/4. So we get 4 minus 1, 3. Obviously, the second one is bigger, as I told you before. So if you do use graph, make sure you show me your graph. So we have antiderivative from 0 to 1 of the upper function 8x minus 4x squared. And we are subtracting the lower function, which is 4x squared. We are taking the antiderivative respect to x. So from 0 to 1, 8x minus 8x squared dx. We have 8x squared over 2 minus 8x cubed over 3 from 0 to 1, right? When it's 0, everything is 0, so you can skip the 0. For 1, this is 4 times 1, and this is 8 third times 1. So we have 4 minus 8 third. 4 times 2 is 12. 12 minus 8 is 4. So we have 4 third here. So the area between these two curves is 1 and 1/3. And all of you got 4 third, right? Now for the second one, it will be easier if you use graph. But if you're not good at your graph, then you have to do the algebraical. If you do use graph, then we know sine is periodic. For periodic function, this is orange. I'm looking for red. Sine goes from 0, go up, and then goes down. And then on the left side, it goes down, and then goes up. And y equals x is straight line. So from the graph, you see that they intersect not only here and there, which is -1 and 1, but also they intersect once in the middle, 0. Anytime between the two points given to you for any interval, if you see any other intersection where they are intersecting, you must split your interval into 2 pieces. So even though they are saying find the antiderivative, find the area from -1 to 1, but you cannot find directly -1 to 1. You have to split them into 2 pieces. One is from -1 to 0, and for another piece from 0 to +1. And in the left piece, our line is bigger, and on the other side from 0 to 1, our sine is bigger. So you cannot use one function to find both area. You have to look at specifically each interval. In that interval, which function is bigger? So if you use 0 to 1, so 0 to -1 to 0, you have to put the line minus the sine function. But if you use from 0 to +1, it's the sine minus the line. And good news, the both parts, they give you the same result. So you can find one area and multiply by 2. So let's do that. We have from 0 to 1. In this part, our sine is bigger. So 1/2 sine pi x over 2. We are subtracting the line 1/2 x. And we are doing the antiderivative with respect to x. Now, for trigs, we have to use U substitution. But for line, it's simple power rule. That's why you can split your dx into 2 pieces. And then you can find the antiderivative twice. The first one is 1/2 sine pi over 2x dx. And the other piece, you can pull out the 1/2 and you have x dx. Now the U substitutions, what says is something cool. Basically, the main idea for U substitution is that take the antiderivative of this and divide by the derivative of this. So basically, you're taking antiderivative and you're taking the derivative. Okay? You didn't realize that, right? The U substitution, the main idea behind U substitution is we are taking the antiderivative of the trig function and you're dividing by the derivative of the angle. That's the U substitution. Okay? So let me remind you about the U substitution if you forgot. If you have sine pi over 2x dx, whatever we have here, that should be U. Because if sine is U, we have to given the derivative of sine, which is cosine, but we are not given cosine. So sine cannot be u. U has to be the inside. So if u is 1/2 x, our du is, sorry, pi half dx. We're only given the dx, not the pi half. So we need to solve. We divide by pi half, but dividing by pi half means multiplying by 2 over pi. So we get 2 over pi du equals the dx. And we have 1/2 outside. So this thing becomes sine u, and the dx becomes 2 over pi du. Right? This is constant coefficient and this is coefficient. So you put them together. As a result, the 2 and 2 cancel out. We get 1 over pi antiderivative of sine u du. Antiderivative sign is negative cosine. So we have 1 over pi cosine u. But they did not give us u. So you can replace this u with whatever we put our u as at the beginning. Now, what I said just now is that using u substitution means taking the derivative of the trig, antiderivative of the trig, and dividing by derivative of the angle. What does that mean? If you do it shortcut, this tells you that antiderivative sign is negative cosine, right? So we have negative cosine pi half x. And then you are dividing by derivative of the angle. What is the derivative of pi half x? Pi half, right? So dividing by pi half. But dividing by pi half means multiplying by 2 over pi. So you get 2 over pi here, and it is that. And you still have your 1/2 here. So they cancel out. What do you have? Negative 1 over pi cosine pi half x, which is exactly same as this one. You see? So the main idea behind u substitution is entire of the trig divided by derivative of the angle. That is u substitution. Okay, then we have the antiderivative of x is x squared over 2. So we have 1/2 x squared over 2. And everything we are evaluating from 0 to 1. So this becomes x squared over 1/4 from 0 to 1. So we have negative 1/2 cosine pi over 2 minus 1/4. We are subtracting when you evaluate the 0. So negative become positive 1 over pi cosine 0. And then this thing becomes 0. So this is the second part when our x is 0. The cosine 0 is 1, right? So this gives us 1 over pi, and this is minus 1/4. Cosine pi half, pi over 2 gives us 0, right? So basically we have negative 1/4, positive 1 over pi. So 1 over pi minus 1/4. But this is right. But this is only one portion of the 2 portions we have. So at the end, to get the entire area, we need to multiply this by 2. As a result, we have 2 over pi minus 2/4. That becomes 1/2. So these are in your homework. And you have many more questions like this. How do you feel about the trig? Not so good, right? This is actually nothing compared to the next one. This one. Here we have to do twice because the area we see under each portion, they don't look symmetric. So you have to find them individually. What time is it? 18. Yep. And we have to split the integral. And again, I'm giving you the picture. In the exam, I'm not going to give you the picture like ln. For ln, it will be trig. Okay. And for you guys, you prefer out the normal function, right? So I'm going to give you the normal function for you, and for ln, it will be something without picture. So ln, make sure you know how to find the intersection without the picture. So this one is, I did it the entire day. I did it, and I keep making mistake. Like I kept it, like for some reason, I don't know why. And then I realized, well, I should give you probably because I made some type of error. So one type of error I see is here. This is 1/14, not 42. So since we don't have time, I don't want to even start. I gave you all the information you need. You just have to split it into two pieces. And then you find the antiderivative by yourself. So let me just give you the setup. This is from your homework. So you have to do it in your home. In the first portion, this is 0 and this is 1. No, this is 0 and this is pi/14. So good thing they gave us our limit. But from the picture, we know that we have an intersection in the middle. So it's from 0 to pi/42. And then in the second part, we have pi/42 to pi/14. And again, for your convenience, I give you which one is bigger in each interval. So in the left interval, 2 cosine is bigger. So it's 2 cosine 7x minus 2 sine 14x dx. In the second interval, the 2 sine is bigger. So 2 sine 14x minus 2 cosine 7x dx. And then you take the entire derivative of each one, and then you evaluate them. Okay? And when you do the entire derivative, you have to use U substitution. So either you use U substitution or you use the shortcut method. The shortcut method is take the entire derivative of the trig, divide by the angle, derivative of the angle. So you have 2 cosine 7x antiderivative. It means you have 2 derivative cosine, antiderivative cosine is sine, right? Derivative sine is cosine. So sine 7x, and then what do you do? Divided by 7. That's the substitution. Same thing for the next one. We have -2 sine 14x. So we have derivative cosine is negative sine. So plus cosine 14x. That's the antiderivative. And then what do we do? Divided by 14. Okay. Evaluate that from 0 to pi/42, and then do the same thing for the other one, and then you get. So I made your life much easier by giving you all the information. But I think in the homework, they will not give you all the information. At the end, you have to select the graph by yourself. So good luck with the homework. We are done at 7.1. In our next class, we are going to do review, only review, okay? Nothing new. So what do you prefer, in person or online? You're not going to learn anything new, only reviewing. Any preference? Online versus in person? Anybody would like it in person? Okay, then you'll have in person. Again, we're not going to learn anything new, okay? We are going to review everything, whatever we have in the review sheet. So make sure you take a look at the review sheet and think about the questions which seem unfamiliar, what you think is hard. We are going to discuss those questions. Huh? Mm-hmm. Yes, you cannot come in person, then join online, no problem. I prefer to be online, to be honest. It's easier for me. Even if you cannot come online, then you have to just watch the recording. Okay. Okay, Andy. Too much? Yeah. So goodbye, everyone. Goodbye, Andy. See you guys all Wednesday. And remember, our exam is next week, Monday.